Type erasure, understanding generic limitations in Kotlin. In this video, we'll explore one of the most important concepts in Kotlin generics, type erasure. This is a fundamental limitation that every Kotlin developer needs to understand when working with generic types. Type erasure is the process where generic type information is removed during compilation and replaced with raw types or bounds at the bytecode level. Here's the key point to remember. Generic types exist only at compile time for type safety. They don't exist at runtime. The Java virtual machine has no knowledge of your generic type parameters once the code is compiled. Let's see type erasure in action. Here we have a simple Kotlin function called printlist that accepts a list of string. The function iterates through the list and prints each item. This is what we write in our Kotlin source code with full generic type information. But after compilation, the bytecode looks very different. The generic type string is completely erased. The list becomes a raw list with no type parameter. Each item in the loop is treated as object, not string. This is type erasure. The generic type information is stripped away during compilation. Type erasure creates several important limitations. First, you cannot perform runtime type checks. The as operator won't work with generic types. Second, you cannot access type information calling t:::: class at runtime is not possible. Third, you cannot create arrays of generic types. And fourth, different generic types become identical at runtime. List of string and list of int are the exact same type to the Java virtual machine. Here's a concrete example of what won't compile. In this generic function, trying to check if a value is of type t using the as operator will fail. Similarly, trying to create an array of generic type t will also fail. Both of these operations require runtime type information, which is erased during compilation. Fortunately, Kotlin provides a solution: Reified type parameters. By marking a function as inline and using the Reified keyword on the type parameter, we can preserve type information. Now the is check works perfectly, and we can even access t:::: class at runtime. The inline keyword is crucial here. It allows the compiler to substitute the actual type at the call site. Let's summarize the key takeaways. Type erasure removes generic information at compile time. The Java virtual machine bytecode only knows about raw types and bounds. You can use Reified with inline functions to preserve type information when needed. And understanding type erasure helps you avoid common pitfalls when working with generics in Kotlin.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.